Good morning.
Morning, sir.
So in a minute or two, we'll start the session.
Good morning, sir.
Good morning. Okay, so let us start the session. People will join. Okay, so last time we have seen the just a second.
Yeah, Ali Mike.
Okay, so everyone can see the slide.
Yes, sir.
So last time we have seen these mechanisms which produce the exact straight line motion. Some point in this mechanism will trace out a line. Its path will be a straight line. So this Peace and Hearts mechanism we have seen, and also we have seen their mathematical proof, how we can prove that these points are moving in straight line. Okay, so we have seen that. Now let us come to the approximate straight line motion mechanisms. Okay, so in this, any one point on the mechanism will be moving in approximately straight line, not exact straight line mechanism. Okay, so even these mechanisms which produce the approximate straight line motion, okay, they also found the applications. These three mechanisms are given in your syllabus. First one is Watt's mechanism. Okay, it is the same Watt who invented the steam engine. What is his full name? Scientist. Okay, so you find out that. Then grasshopper mechanism, Chebyshev's mechanism. Okay, and there are other mechanisms also, but they are not in your syllabus. So we will focus on these three, how they work, which links, how many links they consist of. Basically, all these mechanisms are four bar mechanisms. Okay, arranged in different fashions. Okay, so you can see the first mechanism, which is the VAT mechanism. It has four bar, as you can say. Okay, so first bar is nothing but your fixed link, the line which is connecting to this fixed point O and O1. So it will make one link. Okay, second link will be link OB, link OB. Third link will be AB. Okay, and fourth link will be your O1A. Okay, it is a crossed four bar chain because the links here, they cross each other. Okay, that's why it is called as crossed four bar chain mechanism. So how it will perform? Okay, you can see there will be a point P on the link AB, that is the coupling rod AB connects to the link OB and O1A. So what will happen when you will give angular deflection to the link OB? Okay, so how the motion will takes place of the other two links? This link AB, it will move in this path like this. Okay, but the particular point P will be moving along a approximately straight line like this. If you will focus on the motion of point P, that during particular angular oscillation of link OB, the point P will travel in what path? You can see it. Okay, I will show you the video where you will have a clear idea. So how the motion will take place? OB, link OB will o- oscillate in angular directions like this. Then link O1A, this link will again, it will have angular oscillations. It will oscillate about point O1. Okay, and during these angular oscillations, the link AB will be moving in this path. Various points of the link AB will be moving in this path, and particular point P, which can be found out by this relation. Okay, that particular point P, it will be moving in approximately straight line. So how to find that point, or how to ensure this ratio between different lengths of the link? Okay, so this ratio PB, that is P, say point B का distance to the PA. This ratio should be equal to O1A, that is this link O1A upon OB. If you maintain this ratio, then point P will be moving along a straight line, approximately straight line. Okay, so earlier it was in early times, in the times of steam engine. Okay, when a sliding pair was very difficult to manufacture. Okay, in those days, the scientist Watt used his invention. Okay, that is Watt's mechanism in steam engine to guide the piston rod in a cylinder to have an approximate straight line motion. Okay, so it is a very old mechanism invented by Watt himself. Next, it also finds applications in suspension of trains and automobiles. So I will show you the video from where you will get a clear idea. Okay, so let me take you to take you there. Okay, so see how it is made of. Okay, so link 1, it is link 2, link 3 is fixed link, and here you can see link 4. Okay, it has shown only the points here. So see how it works. So you focus on motion of this point, which is encircled. So its motion is almost an approximate line, approximately a straight line. Very simple mechanism to produce the straight line motion. Okay, its application. See, as I told you that in suspension of trains and automobiles it is used. You can see here this black part which is just behind this red thing which is showing you the animation. This black part is nothing but your Watt's mechanism. Okay, how it absorbs the shocks, here you can see. So its motion will be like this: when vehicle will be traveling and passing the jerks, vibrations to the suspension, then this Watt's mechanism will move like this. Okay, this is okay. So it was about the Watt's mechanism. Are you understanding? Did you get it?
Yes, sir.
Okay. So you memorize this relation, that this relation should be maintained. Next thing is that you know that in comms syllabus, in your term work, mini project is also there. So you can take any of these mechanisms, and if possible you can fabricate a model of it. Okay, what you will need to do, you need to arrange some rods Okay, maybe flat rods of the length. You can decide how much length you want. Okay, here you need to pin down this uh, rod here. So you will need nut and bolt here, and also you need to allow the angular motion. So you will not use the uh, like you will keep some clearance. Okay, so you can fix it at some point. You can attach one another link of required dimensions at point B and at point A, again using the pin joints. Some sort of pin connection you have to use. Okay, and this rod OA, you can fix it somewhere here. Okay, so when you will give the motion, now you need to you need to trace the path of point P. Okay, so what will happen, in order to trace the path of point P, you can uh, provide some arrangement over there. Some provision will be there where you can hold the pen at point P. Okay, pen or sketch or pencil. And when this you will move the mechanism, you can keep a paper in the back of it. So on that paper, that pen will uh, make a line, make a straight line. Okay, so in that way you can prove that it is the particular point is tracing out a straight line. So that will be your WATS mechanism. A mini project will be done. You write a short note that what lengths you have chosen, how you have maintained these geometrical relations. Okay, which links are there, how many links are there, like that. What are the applications? So it will become your mini project. You can choose any mechanism for your mini project. Okay, next next is the grasshopper mechanism. Okay, so you can see that it is a 4-bar mechanism. So which are the links over there? So link OA is one link, then link AP second, then link O1P is your another link. So how many bars? 3 bars, and the fourth bar is fixed one. So you can consider that one end of that bar is at point O, which is fixed, and one end of that bar, fourth bar, is at point O1, which is also fixed. So it makes the 4-bar mechanism. Okay. Now how and which point on this mechanism will trace an approximately straight line? Okay, so you have to extend this link AP, this link AP, in such a way that you maintain this relation. Okay, again mathematical uh, proof is there for it, which we don't need to go into. Okay, so OA, this crank length, okay, which will generally have the oscillatory motion. Okay, it will oscillate between these two position, OA to OA1. Okay, so from OA to OA1, and then again back from OA1 to OA. It will oscillate like this link. Okay, So you need to extend the point you need to extend the link AP, okay, by these geometrical relations. So your OA should be equal to AP square upon AQ, this distance. Okay. So if you will provide these proportions to the length of the link, then what will happen? The point Q, which is at the extension of link AB, it will be tracing an approximately straight line motion like this. Its path, the path of the point Q, will be a straight line, approximate. Okay, so you can check how the links will move, as link OA will oscillate about point O. So this link O1P, this link will oscillate about point O1 like this. It will oscillate like this. Okay, so P1 is showing you the other position of point P here. Next is, what about the as this point P will oscillate in by some angle, the point Q will be traveling along the straight path. Okay, so again I will show you the video of the grasshopper mechanism, so you will come to know actual working of it. Okay, you see it is the grasshopper mechanism. This is link 1, link 2, and this is link 3. So it is a 4 bar mechanism. Fourth bar you can consider between this fixed point and this fixed point. So that bar is fixed. Okay. Now see, this point is moving in a, okay. So this particular point is moving along a straight line like this. Okay. So this is the grasshopper mechanism. Next mechanism is Chebyshev's mechanism. Okay. So again, Chebyshev's mechanism is a 4 bar mechanism. So which are the 4 bars here? O1. Is it visible to you?
No, sir. No, sir.
Okay. 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 So see, Chebyshev's mechanism is again a 4 bar mechanism, crossed 4 bar mechanism, links cross each other. So which are the 4 links? O1, it is fixed link. Then second link is this OA. Okay. Then third is O1A, and fourth is AB. Okay, so how this mechanism works? Again, you have to maintain the some geometrical relations, like the length of link OA and O1B should be same. OA and O1B should be same. Okay, the point P, which is the midpoint, see here, this particular point of the AB, it traces out an approximately straight line P1 P2, which is parallel to O1 O. Okay, so what will happen when you will give angular displacement to any one link? So this link will oscillate about point O like this, and link O1B, it will oscillate about point O1 like this. And meanwhile, this point B, you can say it is the path of point B, B1, B2, and path of point A. So it is also a circular arc, A1, A2, and meanwhile the point P will be having a to and fro motion between point P1 and point P2, P1, P2. Got it? Okay. So what relations you need to maintain? First, this uh, li- links OA and O1B should be equal in length. Next is the point P, midpoint. Okay, we know it. P is the midpoint, and you need to also mention this ratio between the lengths of link AB, O1, OA, S1, S2, S2, 2.5. So if you take suppose AB as 10 centimeter, if you take AB as 10 centimeter, then O1, this distance O1 should be kept as 20 centimeter, 1 is to 2. Okay, and link OA should be taken as 25 centimeter. Okay, so there is one derivation for this, that in what proportions the length of this link should be, so that the point P will be exactly above the point O at extreme position, and exactly above the point O1 at right extreme position. In order to satisfy these conditions, we need to have this relations between the lengths of the link. Okay, again there is derivation for it, and I will ask you to go for that. You will find that derivation in the SS Ratan book. Okay, so sometimes Chebyshev's mechanism का derivation भी आता है. So but I will not cover it. I have already covered the derivation of the straight line mechanism. It is very simple. Okay, you just read and try to connect the two adjacent statements in the derivation. You will understand it. Okay, so this is all the three approximately straight line motion mechanisms which are in your syllabus. Okay, I will also share a video with you. So you see, it is the Chebyshev's mechanism. See how it will appear. The midpoint of link AB is tracing out a straight line approximately. It is a approximately straight line like this, and these two links will oscillate about this point. Okay. So it is all about the approximate straight line motion mechanisms. Now let us go to other mechanisms which are there in this module. So next is your pantograph. Okay. So as you can see here that a pantograph consists of say link 1, okay, link 2, 3, 4, 5. Okay. So these links, in these links there are some geometrical relations to be followed, like length AB is equal to BC is equal to CD equal to AD. Okay. And again you need to follow this ratio, that OA upon OB, OA upon OB is equal to AD upon BE. This. So you will understand that how far you have to extend the link BC to get the point E. Okay. So obviously if you maintain this ratio here, whatever triangles are there, like triangle OAD and triangle OBE, they become the similar triangles. Okay. And now if you give any motion to point D or point E either, okay, so what will happen, in whatever path you move the point D, a straight line or a circle or an ellipse, the same path will be reproduced by the point E, okay, but to a enlarged scale. So here you will get, suppose if you are controlling the motion of point D to a straight line motion, if you are controlling that, then point E will also be traveling in a straight path only, okay, because of the condition of similar triangles. If you are controlling the motion of the point D in a circular path like this, so point E will also trace a circular path. Okay. So a pantograph is generally used for reproduction of plane areas and figures such as maps, plans, etc. on enlarged or reduced scales. Okay. So generally in earlier days, softwares were not available. Okay. And this mechanism used to do that. There are other applications of pantograph also, okay, which I will show you. Any doubt? Okay, so I will now show you the pantographs working and different applications. Just a second. Is it visible, the audio video?
Yes, sir.
Yes, sir.
Okay. So see, so you are controlling the this point, and same figure will be copied here. Okay, so it is also used in machine tools in order to guide the cutting tool in particular path. It is one application. Then see, this is another one, that it is being copied. The shape is being copied. Then here it is another application where this point is not fixed. You can see earlier we have seen these points of the pantograph to be fixed at some point, but it is rotating. We are obtaining kind of straight line motion, and again a modification of pantograph to draw the ellipses. Why I am telling it modification? Because here point A is not fixed. You can see. Okay, so it is about the pantograph. 2 minutes are remaining. Okay, so you have to join back immediately. Now, where is the slide? Yes. Okay, so this is about the pantograph. Okay, next mechanisms uh, are steering gear mechanism. So, how many of you have driven the car or bike? Most of you.
Yes.
Okay, so why steering is required?
No, to change direction.
To change the direction of vehicle, right? Okay, so in order to make that happen, okay, you know that in your hand you have the handle or steering wheel. Okay, but below that there are some mechanism with the help of which you make that happen, that whatever your front wheels are there, you have to turn them. Okay, generally what we do, we steer the vehicle by changing the direction of front wheels. Okay, and you know that back wheels